Welcome to Using Variables. In this lecture, we are going to be creating a location as a starting point. We're also going to be using pseudocode, a method of basically outlining our program so that we can plan what we're going to do in this section and figure out what we need to know in order to get there. And the first thing we're going to need to know is variables, and that's what this lecture is all about. So let's dive right in. So here we are again in front of our project and our console printer. So we know now how to print things to the console, but that's hardly a game, it's hardly interactive. So let's take a step back and have a little think about how we're going to make our game do what we want it to do. So what I'm introducing you to is the concept of pseudocode. So this is not code because we don't yet know how to write these things in code, but it is an outline of what we want to do. It's an outline of that script that we're going to tell our actor to perform. So what do we want to do as the first step? Well, we're basically going off the basis of the rules of our game that we want to have a distance, and then we move, and then we get an updated distance, and so on. So for a start, we're going to set a starting location. So this is where we begin, and that is going to be something that can change so that not each game is going to be the same. Then we're going to calculate that distance, that location from home, and print that distance out to the console so that the player can decide which direction they are going to move in. Then we're going to have to read the player's move, so the player is going to have some way of telling the Unity interface or our game essentially how they want to move. And then we update the location from home and repeat. So once we've updated the location, it will go back through, calculate the distance from home and print the distance again, and the player repeats ad infinitum until we win. And we'll talk about the until we win later on. So what I want to look at now is these first two bits. So far, we've been able to print things to the console which are fixed. You know, we've said in our program that we're going to print the welcome to game go home, but what we want to do is create a possibility for us to input things that are variable, such as the location and the distance. So for that, we're going to introduce, funnily enough, a concept called variables. Now, what is a variable? It's very simple. A variable is very much just like a box in which you can put certain values. So this box, for example, has the value 2 in it, and it also has a label, some number. So that is the label of the box. So quick recap, we've got a box with a label, and inside it there is a value. So that is what a variable is. The box with the label is the variable, and the value is a value. Now, these boxes have different shapes, also known as types. So these boxes will store different types of value. You can't put a square peg in a round hole. So this value in here, this one, an integer, this variable can only store things like this, number 2. A string can only store, well, text items, and you can see it's a different shape. And a float can only store point numbers, so 2.0, for example. So this is because the computer has to store all these things in memory, and it needs to know what shape these values are in order to allocate the right amount of space in memory. So here's a little table to summarize these 3 different types that we will see. You've got integers, which are used only for whole numbers, not fractional or irrational numbers. They can be both positive and negative, and here are some example values that you could put inside an integer box or an integer variable. You have the value 0, you have -1, you have 1.43, so basically any whole number. Then we have float numbers, which are basically real numbers. If you don't know what the term real number means, it basically means anything with a decimal point in it, and that can include rational and irrational numbers. Don't worry if you don't understand these mathematical terms, basically anything with a decimal point. And you can see that in the value syntax, there is this special little f at the end as well to denote that it's a floating point, but otherwise it's just a number with a decimal point, and again it can have a negative sign in front of it. Then finally we have the string, which I told you about in the last lecture. A string is just a fancy name for text, so that is what we can store in it, and we've seen how to make text values in the previous lecture with these double quotes around the text that we want to store. So how does all this translate into code? Well, I'm going to show you. Let's go to our console printer and try and print out a value from a variable. So here it's telling me that I have inconsistent line endings. You may well get this kind of error, and if you do, you simply need to select what kind of line endings you want. If you're on Mac, you'd select Macintosh. If you're on Windows, you'd select Windows, and you hit yes. Basically, this is about invisible characters that are being used to show you line endings in your file, but don't worry too much about that. So how do we go about creating a variable? Well, first off, like I said, variables require space in memory, so we have to declare that we're going to use a variable for the computer to set aside that amount of space. So the declaration of a variable, we have to tell it the type, the shape of the box, and the name of that box. So we start off with the type. Integer is abbreviated to int, so I'm going to start off with the simplest type, the whole numbers, and we will start with a sum number. And you can put a semicolon at the end to say we've finished declaring this variable. Then you can go on to assign to the variable. Assign, what do I mean by that? Well, I mean put a number in the box. So some number equals 1, for example. And then you can go on and print this just like you would print a string with that print function and the brackets around the thing that you're going to print, and then the sum number. And remember your semicolon at the end. Now, because this is a variable directly, you don't need to put quotes around it because the quotes are simply used when you're trying to create a string value. Here what it's saying is get the value out of the sum number variable and print it. So we can save that, head over into Unity and hit play and go over to our console, and you'll see that it has indeed printed out the number 1. Now, if I change some number to a different value, like 134, and go back and replay it, you'll notice that that is what gets changed in the text as well. Now, we could obviously do this with different types too. So now it's time for your challenge. I'd like you to declare and assign variables. Declare a new variable of each type, that's int, float, and string. Assign an initial value and print the values out. And just do a little experiment. I'd like to see, can you assign any value of one type into a variable of another? And if not, what goes wrong? And if so, which ones? Are there any specific combinations? So pause the video and give this challenge a go. Okay, welcome back. I wonder how you got on with that challenge, particularly the last bit. A little bit tricky, a little bit challenging. So let's declare some things. So I'm going to have first off my int called, I'm going to rename it to an integer. Then I'm going to create a float as well, which is just with the keyword float for the type, and then a float, like so. And then finally a string with a string. So all these are declared. I'm going to set an integer. I'm going to set a float to 0 this time, and I'm going to set a string to, well, let's just go with hello. Remember, I'm always adding semicolons on the end of any instruction because our actor is dumb and doesn't know when the instruction has finished otherwise. Now we can go on and print these all out. So I will print first the an integer. You see that Visual Studio is automatically giving me suggestions based on what I type. If I hit enter, then it will automatically fill that out. Same goes for print. It's always suggesting. Very, very helpful of it. And I'm going to also print a string. Okay, let's go back into Unity and hit play. And there we go. We've got the float printed out and the hello. You'll notice that when it prints out the float, it doesn't bother with the decimal points because it doesn't think it needs to. But if I put something in these decimal points and then play, you notice it will bother with the decimal points and it will print everything. Okay, so that is with the correct values assigned. But what if I try and swap a few around? So first off, let me try and put a string into the floats and the integers. Just some random strings. Doesn't really matter what the contents of the string is. And if we go and play, it'll say, oops, there's an error. Now you may see these errors when you mistype things. It simply means go back into Visual Studio and check out what you've done wrong. Now you notice there's squiggly lines under here. And if you hover over, it gives you the error. Cannot implicitly convert type string to float. So that's very easy. Basically, it's saying you've given me a string value and this is a float box and I can't fit a square peg in a round hole. Okay, so that makes more or less enough sense. What about integers if I try and put integer in all of these boxes? Okay, so the only one it's complaining about is the string. It's saying that I can't convert an int into a string. That's fair enough. But funnily enough, it's not complaining with the float. Now, the reason for that is because it can fit a float in here. It's kind of like fitting a circle in a square box because it kind of does fit in. And you'll notice that also if I do it the other way around, so if I put a float in the int, it's saying no, I can't do that because the floats don't include the other way around. The floats include the integers, but the integers don't include the floats. So that's why we can convert in this particular direction. Now let's just set things back to how they should be. And let's make this a float value. There we go, the first few digits of pi. And you see I've got a syntax error, and if I look at it carefully, this error is actually giving me a bit of a red herring to follow, but this first error says new line in constant, and that's because I haven't got this end of my string. So it's kind of including the whole end of the line, including the new line. So that's what was going wrong there. So let's hit play, and we will notice that everything works just fine. Actually, if we hit play, then we will notice that indeed it works fine. So well done, congratulations, you have just been introduced to variables. And just to summarize why we were doing all of that, it's in order to be able to do locations and calculating distance from home. So now we can actually go ahead and make this a location. We can say, let's make it a float because we could be like half a meter away from home. So let's say float location, and then set that location to 5.0, and let's add what is known as a comment here, which is just doesn't mean anything to the computer, but it means something to us. And we always add these to make a note to ourselves. So distance in meters. Basically anything that comes after these double slashes will be highlighted in green by Visual Studio and is actually a comment, so won't be picked up by Unity at all. So I'm going to remove these print statements which it's complaining about because those variables no longer exist, and there we go, print out the location. And let's print out some string before that saying that we're about to print the location. And go back into Unity. Okay, so now it says location 5. So that makes sense. We have done our first step of this pseudocode. We're going to have to figure out how to calculate and print. Well, we've done some printing as well, so we're going to have to figure out how to calculate in the next lecture. See you there.